Alright, welcome everyone. My name is Dwight Duffy, and in this tutorial we're going to review how to calculate a payment for a typical loan. This could be a mortgage loan, this could be an auto loan, this could even be a credit card payment. But what we're looking at here is calculating the payment on a fully amortized loan where we make equal payments over a period of time. Based on some APR or percentage rate. So it turns out that calculating a payment, there's a simple way and a hard way. The simple way is to use a spreadsheet, which is what we're going to be doing here in this tutorial. The more complicated way, of course, is to actually do the math. This is something that I did in a finance class years ago when I was working on my degree, and I had to be able to calculate a payment the old-fashioned way. You can see here the formula. We're calculating the A, or the amount of payment, based on some principal amount, based on some interest rate, based on some number of payments. And it is a pretty arduous sort of formula, something that's well suited to getting a spreadsheet to help us out. So have no fear. We're not going to have to do any of this. We're simply going to use a function called payment, and it's going to do the work of all of this, where we just plug in essentially the number of periods and the interest rate for I and N, and it'll calculate our payment for us. All right, so but it makes you appreciate what the spreadsheet actually does for us here, and what a big boon this was for people and managers who had to use a calculator maybe to calculate these things, or an adding machine device in order to be able to calculate even something as simple as payment on a loan. All right, so let's go ahead and jump in here to Excel. So I'm going to set up a simple spreadsheet where I'm going to compare some loan payments. So I've got an amount of money, I have an interest rate that I'm going to pay, I have some number of months that I'm going to make my payment on, and then based on those three values I'm going to calculate the actual payment. I'm going to calculate my total payments, and I'll just double click in here between E and F, and I'm going to calculate the total interest that I actually interest paid, that I'm going to actually pay, not my interest rate, but the actual interest that I've paid for my loan. All right, and let's pick some values here. Let's get a fairly expensive car, $30,000, and I'm going to get a 0.029, 2.9% interest rate for 36 months. And now I'm going to calculate the payment, the total payments, and the interest paid. And let's compare that against a loan which is the same amount. We'll do a couple of comparisons, and we'll compare that against the dealer rate instead of the teaser rate, the full term loan, which is going to be 7.5%. And of course they're going to try to make it as attractive as possible by setting us up with 60 months. Or maybe I want to call the credit union, and maybe they can get us at 4%, and we'll do 48 months for this loan. All right, so we're only going to have to write these formulas once, and then we'll just copy these values down and we'll be done. Okay, so my payment is going to be equal, so I type the equal symbol, and then PMT, which is the payment function, parentheses, and I can see rate, in per, and PV here. So my rate is, playing Battleship here, B2, except that I need to divide by 12 because I need a monthly rate, because I'm calculating a monthly interest, or a monthly payment based on a monthly number of months. So I need to divide by 12, comma, the number of periods is C2, in this case 36, and then comma, and then PV is the present value, or the amount of money that I'm loaned or that I'm borrowing in this case, so that would be A2. And you can see that that's kind of highlighted those in green, I'm sorry, blue, green, and purple respectively, and that's going to calculate a payment for me. And you can see that the payment is actually a negative number, $871.11. I can actually take that payment then and copy it down, and it will calculate my payment for the 7.5%, which looks like a better deal because it's less money, but we can see that it's for a lot longer term, which means I'm probably going to end up paying more money in total payments. And then 677 is kind of somewhere in the middle on my my 4% loan. All right, so total payments is simply going to be my payment times the number of months, and I don't want it to be negative, so I'm going to use an absolute value function, ABS, parentheses. I'm going to take the number, which is my payment, which is D2, and I'm going to multiply, that's the asterisk, and I'm going to multiply by C2, which is the number of months. And I'm going to get some bigger number that's kind of ugly, so I can come up here, click on the dollar sign to format that out. Maybe get rid of some of the decimal places because I don't really care about the actual pennies for my total payments. I'm just trying to get a rough figure. If I grab the corner now, drag down, I can see that for the 60-month loan at the higher interest rate, I'm going to pay $36,000 in total payments versus $31,000. And the credit union deal at 4% is actually $32,514. So the interest paid is going to be the big number minus the actual amount or present value, and whatever the difference is between those two numbers is my interest, of course. So equal, and I'll go E2 minus A2. And again, we could get rid of the decimal places if we want. And I can see that, oops, I did this wrong. What happened? D2, oh, not D2. Oh, okay, so if you make a mistake like I did, hit delete, sorry, equal E2, so I subtracted my payment, minus, sorry about that, E2 minus A2, and then I get 1360 is my interest for the promotional rate. $6,000, that's the reason the salesperson is actually smiling. It's not because he got you a good deal or saved you 200 bucks or 250 bucks on your payment, but because he just made the dealer almost $5,000 in additional profit on the interest. So you can see that it pays to maybe, you know, shop around a little bit, pay an extra $75 a month, pay it for 2 years less, or in this case I guess it'd be 1 year less, but at a better rate, and save a lot of money. And I can do the same thing on a, if I wanted to extend this out and do it on an expensive house, $450,000, and we'll just pick an outrageous interest rate, 9%. Believe it or not, there used to be a time when people would pay 9% and be glad to get it. 360 months, 450,000, and let's say we did it for 8%. I just want to see what the difference is between 9% and 8% on a 30-year and a 20-year. So that would be 240 months. And again, I should just be able to take these amounts and drag them down. I have to widen out the cell a little bit, but I can see that my monthly payment is only maybe $100, $150, less than $150 different. But look at the difference in the total payments. The interest paid is $800,000 versus, you know, $400,000. These are pretty terrible rates. If we wanted to, we could say, okay, 0.05, and then let's say we could get 0.04, and we can see that how much money, you know, that saves you on your your payment. And again, 4%, lower rate, but less number of years, 20 years instead of 30 years. Pay a little bit more per month, but look at this, you're saving over $200,000 in interest. So definitely worth doing a little bit of, due diligence on your terms of your loan, especially if you're doing something big like a house. And if we knock this down to say 300,000, which would be a more modest sized house, then we could see we're talking about $1,600, $1,800 a month. And again, there's still a big savings in terms of the total payments and the interest paid. All right, so I think that will conclude our tutorial on calculating payments using Microsoft Excel.